Hey, today we're talking about combinations and permutations. As a review, probability. If we want to find a probability of an event, we take the number of ways the event can occur over the sample space, or the total number of options for an event. Now, for the most part, up until now, the way that we've counted this sample space is by simply counting. So, for example, we've talked about the probability of dealing a certain card, and the way that we get our sample space is we just count how many cards there are. Or rolling a die, we count how many faces on the die, and so on. But sometimes finding your sample space is not that simple. In section 3.1, we talked about one way to calculate the total number of a sample space using a tree diagram and the counting principle. And today we're going to talk about two other ways to count sample space. So these problems, by and large, will not be asking you for the probability. They're just going to ask you the number of ways something can happen, the total number of ways. And what a permutation is a permutation is the number of ways you can order objects. And order is the key word here associated with permutation. So we want to take a scenario where order matters. So for example, if I want to alphabetize the books on my bookshelf, the order that I put those in is going to matter. Or if I want to elect somebody to government positions, the order that I do that's going to matter. I want a certain person as president, a certain person as secretary or treasurer. So that's the scenario where a permutation occurs. It's an extension of the counting principle. And let's just take a really simple example. If I say that I have 4 books, and I want to know how many ways can I order them on a shelf. Okay, so let's kind of apply our counting principle. If you recall, we have several events and we're going to multiply them all together. So since I have 4 books, that means that I've got 4 events. And I'm going to multiply all of my options together. Well, as I stand here with my 4 books, the first place in the bookshelf has 4 options. I can put any of the 4 books there. So that's how many options I've got for that first scenario. In the second place on the book, I've already chosen a book for the first place. Now I only have 3 left to choose for that second place. And so this is going to be 3. Then I've placed 2 books. Now I only have 2 left. And then the last place, I only have 1 left. So this is an example of a simple permutation, okay? And you multiply these 4 times 3 times 2 times 1, and you get 24. So there's 24 different ways that I can order those books on a shelf. So now if I ask you a probability problem, 24 would be my denominator. Like if I said, what's the probability I order them in my favorite order? That would be 1 out of 24. My favorite is one certain way out of the 24 total. In math, we have a notation for this kind of arithmetic where you're taking one number and multiplying it by all the numbers below it. It's called factorial, and we denote it with an exclamation point. So it looks like this, 4 exclamation point. And the way we say that is 4 factorial. And what that means for math, it means, hey, take that number, whatever it is, and multiply it by everything below it. Okay, so if I say 10 factorial, then I'm going to start at 10 9, 8, 7, 6, 5, 4, 3, 2, 1. And so these numbers can get really big. Okay. So the more books, and think about it, the more books you have to order on a shelf, the more options there are for that, for those arrangements, right? That number should get quite a bit larger as you add books to your scenario. Okay. Now, we don't want to do this all by hand. How do we do this on a calculator? I'm glad you asked. If you go on class calc and you want to figure out what 4 factorial is, we're going to go to our stat section right here. And right there is an exclamation point. So you type your number first, 4, and then stat exclamation point, and you can see that that's 24. Okay. On the TI, sorry, I lost my calculator here. There it is. You're going to go into, oh, sorry, not stat. You're going into math right here. And over to the far right hand side where it says PRB, that stands for probability. And you scroll down, the 4th option has an exclamation point right there. Okay, so what you'll want to do is start on your home screen, hit the 4, and then come over, hit math, then go over to probability and enter the exclamation point, hit enter again, and you'll get 24. Okay. So that's how you do that. Now, the question is, what if we don't want to order all of the things? So let's say, for example, what if we have 20 books, but we only want to order 4 of them on the shelf? Okay. Some of you probably intuitively know how to do this. I'm going to just show you a shorthand to do it on the calculator. You're going to order those books. You're going to have 20 options for the first one, 19 for the second. Here's how we do this quickly on a calculator. There's actually an operation for a permutation, and it looks like this, NPR on your calculator. Some of you guys might have seen that. It's right above the exclamation point. So N is always the number of objects you have. And R is going to be the number of objects ordered. So N is always your bigger number, and R is always your smaller number. So in this case, 20 books is my total basically on the left. How many books do I have that I'm looking at? And then how many of them are going to be on the shelf is your R value. So what we'd say in this scenario is I have 20 P4. Now those 20 and that 4 are kind of subscripts on the left and the right. They're not next to it. They're not multiplied. It's just a notation. And there's a formula for this, which we're not really going to get into. It involves factorials. It involves factorials and then dividing by other factorials. But for our case, what we're going to do is just type it on the calculator. So the way you do this on class calc, you're going to start with your N value on the left. So you're going to type in your 20, and then you're going to go to stat again. And here's your NPR. See that? Oh, just kidding. Sorry. That was the TI directions. Let's back up a little bit. You're not going to type your 20 in first. You're just going to go straight to stat, hit your NPR. Okay. And then it's giving you a place to put in 2 numbers. You're going to do your N first and then comma then your other number. So 20, comma, 4, like that. Okay. And then this is your answer. So there's 116,280 ways to put 4 books on a shelf if I've got 20 books to pull from. Okay. On the TI, this is the one where you'll want to start in your home screen, and you'll want to start by typing 20, okay, your n value, then you're going to go into math and over to probability and go down to NPR, which is the second option. And then it'll kick you back to the home screen and it'll look like this next to your 20. And then you type the 4 after that. So it's like you're filling in on the left and the right to it, and you hit enter and you'll get the 116280 for your option. Okay. Now this situation, let's jump back to our original situation where we had 4 books and we wanted to order them all. I did that using factorial just to introduce that notation, but this is actually just a straight up permutation. The what's happening here though is that your n and your r are equal. So you have 4 books and you want to order all 4. So another way to do this problem is NPN, NPR, where n and r are 4. So you'd go 4p4. And if you do that on your calculator, you'll get 24, which is what we got when we did the factorial. So I showed you the factorial just so if you see that exclamation point, you know how to handle that. But the way I do all of these problems is when I want to order something, I just go straight to this NPR thing. And sometimes n and r are equal, and sometimes r is smaller than n. That's how I do that. Okay. Keywords for these problems for identification. Any word that implies order. And what I do for that is I kind of put myself in that situation and say like, would I care at what point I was put in that situation? So for example, you know, if you're the book on the shelf, do you care what order you're put in? Well, yeah, I want to be the first book, right? If you're lining up at a door to go to recess, do you care? You know, think of yourself as a second grader. Yeah, I care if I'm first in line or last in line. Order matters in that situation. That's a permutation. So anytime we're ordering, we're arranging. Arranging is a word that implies that order matters. Anytime there's a placing involved, like first, second, third. Do you care? If you're in a sporting event, do you care if you're first or second or third? Yes, you do. You want to be first. Order matters. So if I'm saying like, there are 10 athletes, how many ways can first, second, and third place be won? That's a permutation because I care what place I come in. I think that's all I can think of off the top of my head for ordering, arranging, placing. Okay. Sometimes there's also, I know offices is also kind of a, you know, an ordered implied. So I'm going to say, hey, how many ways can I put 5 people into president, secretary, treasurer, you know, that kind of thing. Where do you care if you're president or treasurer? Probably. Like, you probably have a choice. Order matters in that case. So like, this is anything with president or secretary, treasurer. Those are, oh my gosh, treasurer. I don't know how to spell that word, but this is probably, I mean, that's the typical offices that we say, but anything where I say like, you know, the first person, you know, in this group gets a lollipop and the second person in the group has to, you know, run a mile. Does order matter? Yes. You know, like, you care where you come in that situation. Okay. And then all you do is you look for what's the biggest number, that's your n, what's the smaller number, that's your r, and calculate the number. All right. Sometimes order is not desired, and that is what is called a combination. A combination is grouping n objects in groups of R. Okay, so we're going to use the same notation, except now it's not P, it's C. So if I have n objects and I want them in groups R big, that is a combination. Now, what's the difference between a group, and a line or an arrangement? Well, in a group, if offices aren't assigned or places aren't made, then I actually don't care how I get in a group. If I'm going to take our class and I'm going to put you in groups of 3, well, if person 1, 2, and 3 are in a group, that's the same as person 3, 2, and 1. Right? Like that's a duplicate, if you will. Like that's going to be the same group. And since I'm not assigning offices or orders within that group, there's actually less combinations than there are with a permutation, because anyway, if I elect person 1 first or last into that group, it doesn't matter. They're still part of the same group. So there's a slightly different formula for these, but we do the problems exactly the same. So a problem might look like how many groups of 4 people can be made out of a class of 24. Okay. That's a real simple group right here is your key word, that it's combination, not a permutation, not assigning a job to anybody. I'm not assigning a placement to anybody. I'm not ordering anything. I'm just putting them in groups. So this is going to be 24C4. And it's the same place on your calculator. On the TI, you're going to hit 24. Then you're going to go to your math button. And you're going to choose NCR, and then you're going to put a 4. On class calc, you're going to come over here. You're going to go to stat. You're going to choose your NCR, and you're going to go 24, 4, and you're going to get your answer here, 10,626. So that's the number of ways I can grow, all the different groups I can make out of a class of 24. So that's how a combination works. Group is typically the word that I see most often with a combination. And that's kind of the set apart from a permutation. So when you read one of these problems, ask yourself, is order important in this scenario, or is it not? And that's what's going to get you on the right track with combination or permutation. Now, how do we use this stuff? Okay, so the follow-up question that I can ask to some of these situations, like how many groups can be made out of 4 people? Here's the next question. What is the probability I'm put in a group with my 3 best friends? Okay, so remember probability. How many ways can it occur over the total? So how many groups are there with my best friends in them? If I want all 3 and myself, that's 1 group of a very specific 4, right? So the top of my probability is going to be 1. And what's the bottom? The bottom is all the ways I can make the group. So this number we've been calculating is always the bottom of your probability. So 1 out of 10,626, not very likely that I randomly get assigned to a group with my 3 best friends. Okay, but that's kind of the extension of this. Now, we're not going to get too heavy into the probability side of this. If you end up taking an advanced probability class later, you'll deal with these extensively. They're pretty powerful. You can do some pretty amazing probability stuff with them. But we're going to stay with this as the just a real simple application. Thanks for tuning in. I'll see you next time.